Thanks, Alex. And good morning again, everybody. Thanks for attending. So I'm going to spend a little bit of time today talking to you about AI ethics. It's a very abstract concept, but I hope to kind of serve as a survey and overview of various aspects of this topic. And whatever conversations or questions you might have coming after this will probably be more far valuable than the initial information I share here. So let's get started. So AI ethics. Um, I think ethics itself is a very philosophical concept, right? It's something that philosophers been debating and theorizing for millennia. And primarily, there are like three very popular ways to considering what is ethics and what is ethical. One of them is virtue. Think of the term virtue as tend to be set by a set of rules or hopeful aspirations. Doing the right things, avoiding the biases, and so on. The ontological one is more of a moral framework. Think of like the Ten Commitments or some of these, or even some ways you can consider the U.S. Constitution potentially be a legal framework based on a moral framework. So these principles that guides actions based on a rational interpretation of those rules. Or lastly, the consequentialists. They believe that drive actions that leads to the greatest benefit is really the central principle that should be guiding what is ethical and what is ethical action. So, not to go into the weeds here, what we're discussing here is probably a mishmash of the deontological and the consequentialist beliefs. So somewhere between we're essentially trying to say, how do we establish the framework and the principles to help us leverage AI as a tool, as a technology that can provide the greatest benefit to the world. Not to, not to say that virtue is not a thing to be considered here, but in this conversation, we're just following the combination of the latter two. So here's my personal, very layman interpretation of what I consider to be ethical for AI. I just want to put it out there as maybe as a seed for discussion. So I think the development and implementation of AI to maximize benefit, but at the same time considering the harm and minimizing that harm, and provide that as a service or as a tool to the greatest number of people is a really ethical goal that I personally aspire to. So one of the things I tend to think about ethics when is that if we are venturing this as a profession, as practitioners, into somewhat strange territory, unknown territory, maybe we can borrow from, the experience of other professions that have gone through some of these are relatively mature in how they consider ethical professional conduct. So, for example, in medical field, in the U.S., they take something called Hippocratic Oath, right? So the layman interpretation is first do no harm, but really there has gone through many iterations of following this essentially the same principles, a version of this oath. In that oath, they consider openness, knowledge sharing, treating patients instead of illness, acknowledging the limits of their abilities, and essentially taking the whole profession in this ethical light. And in the legal profession in the U.S., different states have a different oath that attorneys must take, and most of them involve protecting the Constitution, having some sense of honesty, civility, and fidelity towards their patient's cause. And in the financial world, so if you have a financial advisor or fund manager that is helping you manage your money, their highest legal duty is one party to another, requiring ethically acting in the other party's interest. So in the financial sense, means that they cannot put their own interest or a third party interest before your own. So I think there are some elements in all of these that we can borrow from. And also it's comforting to know that all these other professions have found that relatively mature ethical sweet spot in terms of guiding principle to help them navigate all these different principles. So here is the graphics put together, as you can see on the bottom there. by Harvard University. I found this graphics to be very helpful. It is essentially a visualization helping you to navigate through a lot of these different publications. The list of so so the concentric circle. Each concentric circle is a different principle. So you can see from inner to outer is privacy, accountability, safety, security, and so on. And the color coding is really the sector of our society, and the bubbles on the rungs represent essentially the robustness of that discussion, judging by the amount of literature and essentially anything released by corporations or anything by a government agency in that field. So what we can learn from this in just first pass is that on some topics like privacy, the discussion is relatively advanced, and it is, however, in other areas, such as human rights and even in human control of technology, it is still lacking. But in particular, you can see that in the government sector, the discussion is, obviously spotty, and that is something that for the development of AI ethics is something that should be made up. So some of the ways that I kind of tend to look at AI ethics is breaking down by various principles. One of the first principles is really the idea of transparency. So I think this idea is, not just unique to AI development or AI implementation, but also happens a lot in other data-related fields, right? So how is data used to train the AI collected and curated? So consider the idea that if the data collection process is really a legacy of existing systems, and a lot of existing systems having intrinsic biases, then we should at least be made aware, or as we're building these AI model, be aware that data is flawed and data in itself is intrinsically biased. And how the curation is very important, because a lot of the curation and transformation that happens to the data could create a bias in that process. Take an example, right? So a lot of these data labeling services are scattered all over the world, and the breakdown of the services provided generally is really done by language and done by a certain type of domain expertise, but there's very little consideration of cultural understanding. Even in the English language, sometimes as plain as different usage words. For example, in Ireland, they say grand, they mean just, oh, it's fine, it's okay. But in the United States, that word carries a much more positive connotation. So that's just a very small example of that cultural misunderstanding or cultural difference that can lead to a skew in the transformation of data. So where are we interacting with AI? So there's a story that about 2 years ago, New York City decided that they want to run an audit of all their decision-making algorithms. They didn't know how many they had. They didn't know where they were. They didn't know how the decisions were made and who was impacted. And after assembling a commission and 2 years of investigation, they realized that all of them are essentially black boxes. Even after all that work, they understood less than 10% of all those algorithms. And these algorithms are affecting everyday lives. They're allocating where city services go to collect garbage, fix roads. They're deciding which kid goes to which magnet school potentially, which neighborhood requires more housing assistance, and where should affordable housing be built. So all these things that regular citizens in the city might not be aware about. So having that transparency to acknowledge and letting people know that how their lives are being impacted, even when they're not choosing to interact, is important. And which services provided to us include AI components, like I mentioned in that city example, that could be definitely a deterrent to people's amount of trust. And is there also an alternative to AI-based services? So as we saturate more and more of our daily lives with technology that has AI components, sometimes we have to stop and think, well, what if somebody, for religious purposes or cultural purposes or purpose of personal preference, they do not want to choose the AI-based services? Well, sometimes what if they go the way? What if the regular human to human services go the way of fax machine or Telegram? What if they are no longer an option? What are those people supposed to do? And of course, there's a trade-off to transparency in that if studies, a few papers have shown that, especially using Lime SHAP concepts I will introduce later, techniques to essentially make a model explainable, enough of those tests to linearly approximate a model can produce enough data to essentially reverse engineer the model itself. Now, that could be a really important concept because if something that is making important decisions is reversely engineered, that opens it up to hacking for people with technical sophistication to essentially hijack and leverage that insight to their own advantage. Somewhat related concept here for principle is this explainability. So this is a little bit more a nuanced model-specific principle. Which features are being considered by the model? What weights and what gradients are being associated with that? And how? But the additional step beyond that interpretability and kind of elevating this to explainability is that last step is the communication regarding the model's decision logic to the human. Right now, even if we do decide to, take apart a model, truly understand what it does, 99% of the time, as far as I can see, I've never seen an example where that knowledge has been translated to a language or in a communication model where that could be communicated to the end user to help them understand how their decisions were made. And this is actually now emerging, I don't know, like call it subfield called XAI or explainable AI. And on DARPA's website, here is their particular definition of it, is that they want to build a more explainable model and also enable human users to understand, appropriately trust, and effectively manage emerging generation artificial intelligence. So this is something that I think there deserves much more research, and there is already a lot of exciting stuff going on right now. But the what's falling behind here is the adoption of what's already relatively mature techniques into the existing production process. And another principle that is important here is consent, right? So does users have the option to opt out? Do they have the option to opt out partially of AI technologies? And how do and also sometimes it's not even opting out, for example, a mobile app that has AI elements. For example, if they're an avid Facebook user, do they understand the impact if they decide to not allow the Facebook to collect their data? Do they understand what services will be denied to them? Do they understand what what decisions will be made by the lack of data by Facebook that might affect their user experience or by or the content they're being shown and the connections they're making on Facebook? Inclusivity. So this one is relatively broad, but I think the end goal is pretty obvious. Is the idea that AI's technology, especially, is one of those technologies developed in such an open source environment that it is a technology for the people, from the people, by the people. And what that means is that it should be free from biases. It should not be a tool to produce discriminatory decisions, even if the data that is used to train the model is inherited from a legacy of a bias. A good example is that there was a algorithm called Compass that was predicting prison recidivism. But of course, in prison population, there's a huge racial bias, and the data collected inherits that, essentially existing phenomena. But the model itself is still is a continuation of bias. Just because the data was biased to begin with doesn't give us really an excuse to say, well, throw our hands up, there's nothing we can do about it. Let's just build a model based on what we have. Development loops should include users as stakeholders. A lot of times these things are built behind closed doors. End users, whether it's B2B, B2C, or B2G, the stakeholders are sometimes kept out of the loop until the model is built or nearly built. And the iteration process a lot of times do not have direct feedback from the user. And that's really important because having revenues for redress and having even a broader public uh, essentially reflect on unforeseeable impacts from these AI models is important. And then, of course, for that to happen, a lot of it has to do with the general public having improved data and AI literacy. Otherwise, it is much harder to communicate the explainability piece, but also it's harder for them to really gauge the impact on their personal level, how to adjust their exposure to AI, and what is their comfort level, and what kind of regulations uh, proposed by politicians are more suitable or closer to their personal beliefs. Last piece is the government politician piece, is the oversight and governance. Right now, there's relatively vacuum to this. Not to say that there isn't some valiant attempts, but I think what we're lacking here is more of a discussion between all the different um, jurisdictions. So from cities to state to government to global level, there's lacking a unified discussion on what is important and what are some of the legal frameworks that can be established, and what are for example, a lot of these corporations, right? They have to have their books, their accounting audited by a third party. Right now, there is no such audit, kind of services really widely available, or a need by oversight to do that. And also, that the global discussion, that private-public partnership discuss what should be some of the industry standards for approval and usage. What are some of the measurements and metrics that can be used to not only assess individual AI performance and but also compare them across each other. Now, one of the technical challenges here, in addition to all those different techniques to pull apart these more black box models, is the idea of data. Imagine if we were to have a agency available that is um, overseeing AI algorithms, and that is affecting people and making sure that is free from bias. That agency will need to have a substantial data set to essentially as a tool set to test against a range of different AIs. And of course, that the composition and the collection of that data, generation of that data, has to be kept very secret. But at the same, and then the data set itself has to be substantial. So to adopt all the things that we talked about, how do we move forward to go from these principles and theories and ideas to actually on the ground implementation? So break it down so the first challenging area is legal, right? So ownership of the data and data products. Right now, I don't think there is a very clear-cut jurisprudence to define, especially on the internet and social media, like once your data is collected, who owns that data. GDPR and CCPA do help define that somewhat, but of course, they're highly patchy in terms of how they define ownership and also the region where they're taking effect. But also, we already seen that the cost of compliance just to that, essentially our first giant step towards this completeness in legal framework, is already substantial. And a regulation oversight needs to be consistent so that we don't run into necessarily a situation where like all the banks are in Bermuda, right? All the technology companies have like subsidiaries in all these different countries to hold patents. So the regulation oversight, if there is not more of a universal coverage and common understanding, then that the regulation oversight will be rendered relatively ineffective. And lastly is the governance and enforcement. So a lot of these technology-related issues depends on where they emerge in the U.S. They're either part of the Federal Trade Commission or the FCC or the Federal Drug Administration. all these different agencies essentially cover small pieces that are related or adjacent to this technology, but not necessarily directly overseeing it. And associated Office of Inspector Generals of these agencies, and also to more of an enforcement role, the federal agency and local governments are really lacking the expertise, the talent, or really the mental fortitude to really tackle these issues. While if the rule is violated, what is the civil and legal enforcement revenues that they can take to make sure that people are not being discriminated against, or that AI in itself essentially is running rampant without checks. So the existing frameworks here is that we have CPA and GDPR. Personally, I think they are a fantastic first start, especially GDPR includes what they call a right to explanation provision. So in that provision, specifically spells out that no AI should be solely automated. So there should be a human in the loop, and no AI should result in legal or serious negative impact for individual. And also requires necessary assessment, providing meaningful information about the logic of decision-making process, appropriate mathematical statistical procedures, obtain human intervention, allow the end user to obtain human intervention, express point of view, obtain an explanation, and the organization that has built AI is required to provide technical and organizational measures. So you probably, as practitioners, you probably notice that all these sounds extremely vague. None of these measures or explanation or procedures or process are legally defined or even technically defined in GDPR. So I think that's where a lot of us practitioners can step in to really bridge that gap on what these well-designed measures want to achieve and how to achieve it on the ground. Of course, there's a lot of technology and business opportunities involved in making these real and on the ground as well. And also, the Civil Rights Act and the relatively similar Employment Equality Framework Directive in the EU. These are similarly can be leveraged to essentially go after models that is resulting in biases against protected groups. So protecting people from discriminated by AI in terms of gender, sexual preferences, religious beliefs, and so on and so on. And lastly, I include FDA approval processes because, quietly but surely, there's already have been more than 100 AI algorithms and AI-based devices and AI drug development processes that's already been approved by FDA. So FDA has been quietly, essentially leading the way in terms of how to vet AI technology before releasing it to the public, and they have even you can argue that even have a much higher threshold of evaluation, because a lot of these things they do will end up impact people's quality of life or even life itself. So some of these later newer proposals are proposed in the U.S. and the HRs essentially represents House Resolution, S stands for Senate. So these are bills that has been brought on the floor, and most of them have passed at least in one house. But as you can see from their names, a lot of them are superficial and area specific. So what we need here, ideally, for the government to send a clear message to the industry, is some overarching guidelines rather than just spotty ones that target specific type of product or a specific type of application of AI. Another type of adoption challenges is cultural. So region, age, education, and other demographic markers have been shown in surveys over and over again to essentially have this, almost like a gap in how people see AI, how people trust AI, and very likely leads to different degrees of adoption and different way of regulating AI. This is a data set, a survey performed by Ipsos in 2018. And then you can see that by country, light blue represents, so the question posed to the surveys is that how do you trust AI? It's a very straightforward question. As you can see by country, it varies a lot. And what do you notice that China's on top, and their its neighbors South Korea and Japan are very much on the bottom. So it's not just a regional issue, but it's also could be by country issue. And you can see the United States is more of a mixed bag, somewhere in the middle next to New Zealand and Australia. So I think this is something that to keep an eye on, because as AI emerge as a productivity tool, um, if adoption rate due to cultural differences and cultural and this implicit trust as society in AI is different, that could introduce another element to introduce this wealth inequality between countries, and also this essentially who is going to be left behind. And here is a survey performed by the Center for Governance of AI. This one is much more comprehensive in covering a multitude of different demographic markers. You can see that age, you'll imagine age would be much big um, factor in determining it, but younger people seems just to be marginally better at trusting, well, marginally more trusting in AI. Men tend to be more trusting than women. I think the biggest trend you can see here is that higher education and higher income tend to correlate with kind of expressing higher trust. Also, what's really interesting to me is somewhere down here that you see CS or engineering degree versus no CS or engineering degree. Not surprisingly, people with exposure to computer science and engineering and programming have shown more of a trust in how in accepting AI. And lastly, this is where I'm going to spend a little bit more time. Uh, the last bit of time we have left here is that the idea that what are the technological challenges. So firstly, we're talking about the cost of adoption as standard practice. As of today, the pure pursuit of AI essentially is performance. How well can your model perform in terms of accuracy, in terms of running as small of a network as possible on a mobile device? How fast does it run? How many, how fast can it return result, and so on. But what's I think was what we're missing is an opportunity here, because the techniques, as I talk about a little bit later, in helping parse out the logic in these machine learning models and deep learning neural networks, can is in turn a tool to help us tune those networks and models to perform even better. But right now, that additional cost of essentially doing another step in this development cycle is not really standard practice. Industry trend to low-code solutions. So as we can see, there is definitely a lot more essentially these gray boxes and black boxes solutions that's promising to perform specific type of task very well. And also there are essentially these platforms that is telling you that, oh, you don't really need to write code. You can just essentially click buttons and select which one is having automatically better performance metrics, and then one click you're going to production. Both of these type of offerings definitely hold their appeals, and that's why they exist and they have a niche in the market. But however, in the long term, I think a lot of these buyers of these products, government agencies, larger corporations, have to realize that they do want to adopt transparency and explainability in their models. Adopting local solution might become an obstacle, a burden down the road, rather than a good first step, because then they essentially rely on third parties to develop solutions that satisfy what is industry compliant for them and what is intrinsically considered ethical to their standards. And then lastly, the trade-off between faithfulness and completeness. This isn't like more of a technical concept. Is that a lot of techniques that I'll talk about in a little bit here is that is to describe such a complex system. There's, it's almost impossible. Essentially, trying to describe the entire planet Earth in one sentence, right? You can say it's blue, or you can say it's mostly water, or you can say something. All of those things are true, but most likely those are only things that are true for very specific parts of it. And to really deliver that information to balance faithfulness and completeness to the end user is a balancing act that I think will be a challenge for a lot of practitioners and organizations. So specifically, I'll touch on four type of approaches, techniques, or tool sets here to help parse out the essentially the intricacies of the model logic. Well, I just want to highlight here, a lot of these are, kind of came out a couple of years ago. Um, Conceptually, I think this was really important. I'm not entirely certain that most of these have a .NET implementation, but if they don't, I hope they get on that. So the first one is called Lime or SHAP. The concept of these, what they call linear proxy models, came out first in 2016 paper called "Why Should I Trust You?" I think it's a very aptly titled paper, right? It's a question that is getting asked more and more by end users. And what this really kind of is a trade-off between local versus global interpretability. Let's take, for example, let's think about, if you have a two-dimensional projection of high-dimensional clustering, and then and you're trying to do a binary classification. A lot of that really having to do is finding that decision boundary, and decision boundary might not be linear. And a lot of these models, in fact, their advantage is that they are nonlinear. Now, when you input a specific set of inputs, let's just say, dog or cat, and you input image of a dog, and then that particular image of dog might be a data point in that two-dimensional projection, all the features on one side of that decision boundary versus the other. But to know the gradient, or to know the localized decision boundary that is making that decision of a dog versus cat, is what this technique is trying to do. Essentially, it's trying to draw essentially the tangent line of the decision boundary that's closest to the data point you're trying to decide in this binary classification case. All right, and then another popular techniques that is gaining a lot of attention is called Kraken. It came out in the paper in 2016 called Visual Explanation from Deep Networks via Gradient-Based Localization. Excuse me. So what this technique is trying to do is that it came out as essentially trying to explain trying to help visualize how convolutional neural networks interprets an image as a signal, and how those signals lead to node activation, activate, activations in the various layers of the convolutional neural network through occlusion. So meaning by purposely and iteratively blocking part of that image as a feature inputs, and then see how those occlusions might impact the decision outcome of that decision interest. And then by propagating through the system to calculate the gradients in each case of occlusion, it generates a visual representation. Essentially, it's a heat map. For example, dog versus cat. It might be focusing on the long bushy tail, or it might be focusing on the more elongated face and pointy ears to identify its features that is contributing mostly to the decision that is the dog instead of the cat. Lastly is a related technique called deep lift. This is also a technique like Kraken called saliency mapping. And so this one came out a little bit later in 2017 in a paper called Learning Important Features Through Propagation Activation Differences. A little bit different. So even though it's a saliency-based techniques, what is different from GradCam from GradCam is that like GradCam is gradient-based. This one is not. This one is more of a okay. Instead of calculating an ingredient, let's see if we can just do one fast backward pass through the network and then infer the weights. And that's really what we're interested in, anyways. And then see if we can identify based on weights which nodes and therefore features are leading to the final decision. However, this one has a drawback that can be hard to evaluate because for each network, sometimes for even in for each decision, the weight value are essentially evaluated relativistically. Uh, so choosing a baseline, so to compare all networks, all decisions through a single network requires more experience and expertise. All right, just do a quick time check here. So Lucid, Lucid is a tool that is provided by Google. Came out essentially in blog post in 2018, the building blocks of interpretability. It's not so much similar. It's different from the previous three that I talked about because it's not really a technique or approach. It's more of a collection of tools. It's built with TensorFlow, has a collector infrastructure and tools, including GradCam and some more interesting ones, including serial network related, kind of evaluations that you can, quickly spin up and leverage to essentially evaluate the performance of a model, but also understanding how the model's making those decisions. And what's good about this is that it does have, because it's built through TensorFlow, it does have a variety of different APIs, and it includes a model zoo for all the pre-trained models for someone to quickly spin up, retrain the pre-trained models, and even just play around to understand some of these more novel techniques that they have included in this library. And also, what's really interesting here is a lot of things I talked about before, as I mentioned, that idea that local tangent of a decision boundary, or the specifically of the process of occlusion based on a single image input. Those are still relatively local understandings, meaning that you by performing it once, you understand how the model performs against a specific set of inputs. In this library, they provide some tools to help you gain some global understanding in terms of, for example, in neural networks, how some of the nodes are essentially there's interplay or interactions, the primary interactions between some of the more quote unquote important nodes. And that can gain some more generalized global understanding in how the model performs. So what's next? I think there's a lot. There's a lot that we have covered, that we have gone over, and there's a lot more to do because each one of really the aspects, each one of the slides really deserves a work stream or longer conversation itself. I think one of the first things that the industry can do is reaching consensus. Um, I believe that this is one of the scenarios where the industry start reaching consensus, work together, start regulating ourselves, then we won't run the risk of the government or somebody um, who is more driven by the principle and even the appearance of regulation to implement rules that is not reasonable or that's not really realistic. And having that happen to us rather than having us as practitioners and as an industry build a framework, I think who can end up having a long-term difference. Again, I want to iterate the importance of data AI literacy efforts. Sometimes I will go to like high schools, talk to high schoolers about what AI is, like what are given examples, and even help them like build a quick model. Just having that initial understanding of what AI is in the general public, I think it will facilitate much better and friendlier and productive conversations in how to really implement AI ethics. And having that public-private academic partnership essentially something that we have already seen in a lot of different scientific sectors, and even in AI. But specifically, extend that partnership into this topic. It's just having this circular flow of findings driving policy and policy guiding finding and so on, and of course the private sector providing investment and acceleration in that cycle is key. And of course, AI is an area that is fast evolving. We can always use more funding into more research. I think that's something that in the private sector, in the U.S. at least, that's definitely an advantage. But the government is still relatively lagging behind. I think just last year, it just passed less than $3 billion in AI specific funding. That's really a drop in the bucket, especially if the government want to have a say in where the technology is going. I think more direct funding into targeted research areas is really crucial. So I have gone through quite a bit of content. It's a very rich topic. I hope that this is enough to get everybody started thinking, and lead to a longer, richer conversation amongst us, and even maybe some kind of if you have more interest, please let me know. We'd love to discuss this topic. And there's definitely organizations, at least part of that I'm part of in the U.S. called ACT-IAC, that is currently working on AI ethics advisory to the U.S. government, hoping to gain some more attention and lay some groundwork to guide the future policies in how this area will be made real. Again, thank you everybody for your time. This online conference thing is fantastic, and I hope you enjoyed it as much as I have.
Thank you, Henry. That was awesome. So if you have any questions, you can ask them in the chat. I already have one I want to ask you, Henry. So
Sure.
do you think there'll be a specialization in kind of data science ethics in the future, or is it something that will just be something you have to do as a data scientist?
I hope. I think a lot of data scientists want to do it. I really do believe that practitioners, it's just, we're naturally curious people, right? We're practitioners. We like to tinker. We like to build. We like to learn new things. And to build something that we made ourselves, but not really understanding the full intricacies, I think personally, I have a lot of curiosity to want to know. And I think that curiosity is shared by a lot of practitioners. But unfortunately, I think unless when we do work, a lot of times the time is such a crunch. We don't have that luxury to say, oh, I'm going to take 20% of my time to work on an explainable piece of this, if it is not a requirement on a project. So I think even though practitioner would love to do it, um, they still have to have the backing and the time allocation, the resource backing from the companies, and the companies are unlikely to do it unless there's some kind of compulsion in terms of compliance or regulation. So that's how I see it today.
Sure. Okay, great. We have a question here as well. When I studied biomedical engineering, I learned how to fill out an ethics committee application before setting up an experiment. Should CS students learn the same? Should there be an overarching ethics commission for novel usage of AI?
I think that's something that is, if we can have something set up like that, that'd be great. I think, especially as I mentioned before, FDA has already approved a lot of these AI algorithms in terms of medical imaging. We already had our first antibiotics that is developed using AI techniques, right? So all these are that are affecting people's medical decisions. So there should be no difference in how those AIs, your data scientists or machine learning engineers should be operating compared to a biomedical engineer. So I completely agree on that front. There should be some kind of ethics submission, and there should be some kind of professional ethical code to guide practitioners.
Cool. Another question we have here is, what do you see the role of citizens and end users in this discussion?
I think at least in a democratic society, a lot of these regulations don't happen unless people ask for it. there can be academics and corporations there, whispering to government's ear in terms of what they believe is the right path to go down. But a lot of times, um, they don't become, at least in the US, they don't become campaign issues, they don't become bills, they don't become, laws, unless the citizens are actively asking for this. So as citizens, I think one is this generalized idea of data and AI literacy to for more people to familiarize themselves is, not just conceptually how this works, but how exposed they are in their daily lives to this type of technology. But the other one is, certain type of activism. For example, we recently had a presidential candidate, Andrew Yang, right? He was more of a technocrat. So a lot of these AI related topics were more part of his campaign platform, and a lot of support he did receive was based on his stance on those topics. So there could be a certain level of activism and organization that can drive policies.
Okay. Well, thank you very much, Henry. This was a fantastic talk, and thank you all for answering all the questions as well. You have some great feedback in the chat here from the audience. They really much appreciate this.
Oh, thank you, everybody. Thanks,
Yeah.
Alex.
And next up here at the full hour, we're going to have Jernay Kafka from Brisbane giving us talk about an introduction to ML.NET. So definitely stay tuned for that. But before that talk, we're actually going to go and listen to Mihai, who is using ML.NET in his organization. So we're going to listen to an interview with him. So thank you, Henry, and stay tuned for the next talk at the full hour. It's great to have you.